will bring it. So here I'm going to, I think the same diagram, yeah, same diagram will work out. I'll take help of same diagram instead of drawing. I'll slightly modify this. Let me, I'll rewrite this data. The rest of everything will be same. Okay, here from the ball will be projected from the ground from certain height. So it will come and strike the ground u/g. It will ascend here to u/g. Then 3u/g. By the time it comes here, 4u/g. Then it will descend 6u/g. Then this will be 7u/g. Like this so on. So t equal to 0 will be this one. So what is the thing? A ball is released from rest at a height h from the ground at t equals 0, and it bounces, or select it collides elastically with the ground and rebounds to same height, and the motion and such motion repeatedly occurs, and such motion repeatedly occurs. So we'll assume that elastically means no loss of energy here. Elastically means no loss of energy. Let's plot the graphs again. So for first it will undergo here. So it is release from rest. I think a little bit you have to be careful when you are plotting the graph. Some other colors so that it will be. No, it is the ball is released from rest. These are the intervals. I'll come later on. It is released from rest. So what is initial velocity? Velocity meter per second. Okay, there's time that one. So the graph will be first the velocity directed vertically down. I'll take positive. Then little bit some. This is a t equal to 0, u by g, 2u by g, 3u by g, 4u by g, 5u by g. T is in seconds. So it will go and strike the ground with a speed u, then immediately to rebound. This is this part of graph very confusion. I'll release from rest. By the time it strikes, by the time it reaches the ground, it will strike with a speed u. Okay. So here, what is the convention? Positive. This is a negative. Previously, what was the convention? Upward was positive. Downward was negative. You will get this. So here now come for this one. This downward direction, any quantity measured in the downward direction will be taken as positive. It will come and strike the ground with a velocity u. So therefore, this should be positive. Immediately after impact, elastic collision, no loss of energy here. The velocity will be directed vertically up. So this u will be negative. So very next moment, this u will become negative. Then again, what is the motion? First accelerated motion. Then changes direction. Then again, what is the type of motion? Will be retarding motion. So from here now accelerated motion. Collides due to collision, there'll be change in direction of motion and no loss of energy due to elastic collision. Then it's going to undergo retarding motion. The velocity keeps on decreases and comes to instantaneous rest. Then again it will fall back. Again start accelerating. Again come and strike the ground with speed u. Again it will undergo retardation. So this was the graph here. What about the speed versus time graph? Speed will increase. Okay, that one. Then again start decreasing. Then again it will increase. Again it will decrease. Again it will increase. Like that it will decrease. U by g, 2u by g, 3u by g, 4u by g, 5u by g. This is a velocity. Sorry, I should write v bar. Okay, able to analyze the thing. So this will be the direction of motion. If you say speed should not be negative, no. So therefore, only positive values have to be taken. So the curve will be like this. If you plot VT graph, velocity of time graph, it should be like this. So now look at this one. So here the velocity of the object will increase due to collision, changes direction of motion. They'll undergo retardation. Then again. So it will freely fall. Where is the freely falling? Freely falling is this one. These are the freely falling. What about the position versus time graph? It was a test. So therefore the position versus time graph will be it is little bit. Okay, now I'll put it here. This, yeah. There's a position. Okay, this is u/g. Some other color, contrast color, I'll take it. u/g, 2u/g. So on node basis, okay, you'll do one thing. What should be the slope? Should be 0, no? It was released from rest. Look at this, ball is released from rest. Slope should be 0. Then speed will increase. Then the slope should increase. It collide with the ground. Just after impact, the direction of motion changes. So therefore the slope should be negative. Again, they undergo retardation. Again, when it reaches at highest point, it'll come to instantaneous rest. Slope should be 0. Hope you are able to understand this. I just explained for one oscillation. Release from rest. So slope should be 0. Just just after impact, the direction of motion changes. So the slope, what happened from positive slope should become negative slope. Again, undergo retardation. The slope should decrease. Comes to instantaneous rest at highest point. Again, it will start freely falling. So the freely falling motion is this one. The returning motion is these things. Okay, like this for a body projected, for a freely fall, for a body projected from, for a freely falling object. So we can write this particular graphs here. This is body released from a height h at t equals 0. Then what about the velocity, speed versus time graph? Okay, the curves will be of this nature. See, we have to analyze here. There's no other way. We have to fight with the basic concept here. Let me